Cool, ma. So earlier, last time we discussed all logarithms, no? You remember that, no?
Yes, sir.
Okay, tell me what is log A by B?
Sir, log A minus log B.
Very good. Log A by B is log A minus log B. What is log AB?
Log A
Log
plus
A
log
plus
B.
log B.
Log A plus log B. Okay. Then log x to the base A power this. What is this?
Sir,
Sir,
A
x
log
power.
by
X
log A.
by A equal to the power.
This
What?
should be equal to x, right?
Yeah.
Oh, okay,
Somewhere.
very good. So you remember basic logarithms. Okay. So this kind of problem you can do, no? Okay. See what exactly we are doing here. This kind of limit. Okay, obviously denominator is becoming 0. See, 2a plus 5a, 7a, again 3a plus 4a, 7a. This kind of problems we did, no? You guys also have done, right? What you have
Yes,
done?
sir.
You are doing actually double rationalization. You are rationalizing the numerator also, at the same time denominator also. Okay, ma?
Okay,
Okay,
sir.
sir.
Okay, you can do it, no? Just convince yourself that this is, you can do it or not.
So now we'd have to do it now, yeah?
No, just convince yourself. This will work, no? Agreed?
Yes, sir.
Okay, okay. So this kind of limit, see. Okay, so earlier we have discussed one kind of limit. What is that? 1 plus x whole power 1 by x when x tends to 0. Right. You remember this limit, no? We started with compound interest and we arrived at e, right? You
Yes,
remember
sir.
this one, no? This limit. You remember, ma?
Yes, sir.
Yes, sir.
Okay, very good. So now similarly we have one more limit. Okay. So okay. So you were told about this thing, right? Logarithmic differentiation, right?
Yes, sir.
Now you know what is logarithmic differentiation, right? So for example, a power sine x, or let's say a power x. If you want to differentiate, how will you do it now? Tell me.
So it becomes x log A.
It becomes a power x log a. Okay, ma?
Mm. Sir,
Okay.
wait,
So
what?
what we do is y equals to a power x, right?
Sir,
Then
shouldn't
we
it
take
be X log A?
what, ma?
Shouldn't it be X log A?
No, it is not x log a. It is a power x log a.
Oh, wait, what?
Okay, so let's try this, no? Log y equals x log a. Okay, that is log y equals x log a. Still you have to differentiate, no? You did not differentiate
Yes, sir.
yet. This becomes what? 1 by y dy by
Into
dx,
dy by
right?
dx. Yeah.
This becomes what? Log a, right?
Yeah, sir.
Yes.
Log a is a constant, right? This becomes what? Dy by dx equals to y times log a, right? But what is y? Y is our a power x. Okay,
A
ma?
power x. So A
That's why
power x into log A.
a power x log a. Okay?
Oh, sir, I thought you were not saying the final answer. Sorry, sir.
Okay, understood, no?
Yes, sir.
Hmm.
Okay, so a power x log a. Okay, now let's say you have something like this: a power x minus 1 by, let's say, x. Okay, again limit x tends to 0. What will happen here? This becomes a power 0 is 1, 1 minus 1 0, 0 by 0. Agreed?
Mm.
Sir, we
This
need to
is
use
in
u
0
by
by
v rule.
0 format. Then what should we do? We'll
Sir,
apply
the
U
L'Hopital
by
rule.
v rule.
No,
quotient
not
rule.
differentiation. We are talking about limit, right? This is
Oh,
in
yes.
0 by 0 format, right? 0 by
Oh,
0
yes, sir.
format, what should we do? Now we have to
L of
resolve the issue, right? What should we do? We rather
L of
differentiate numerator and denominator. If you differentiate numerator, what will happen? A
sir
power
ax
x
is yeah.
and a. Okay. If you
Okay.
differentiate denominator, what will it become? It will become 1.
1.
Now you can substitute 0, right? It becomes what? A power 0 ln a, which is equal to ln a. Okay, ma?
ln a. Yeah.
ln a,
Yes.
right? So,
Yeah.
Yes, sir.
so this you are clear, no? Now let's say e power x minus 1 by x. What exactly is this? This becomes e power x ln
By
e
1.
ln e by 1. That's it, right?
Yeah.
But what is ln e? Ln is actually equal to 1, right?
Hmm.
Agreed, no? And when you say
Yes, sir.
natural logarithm, that means it's to the base e. Log base e, e to the base e should be equal to 1. E power 1 is e, right? No?
Sir, in the previous case, can you explain how it became a power x ln a?
A power x ln a. So a power x minus 1 we differentiated. If we
Yes, sir.
differentiate what? A power x minus 1 d by dx of earlier we differentiated, no? A power x differentiated, then we got a power x ln a, no? Remember that.
Oh, okay, sir.
Remember, a power x if you differentiate, what will you get? A power x if
So
you
that
differentiate.
itself.
If you differentiate, what you are getting? A power x if you differentiate, you are getting a power x ln a, right? No?
Yes, sir.
Well, that's what we have written. We are differentiating numerator and denominator separately. Basically,
Okay, sir.
we are using LH rule, f dash by z dash. Okay,
Yes,
f
sir.
is this and g is this. F dash by z dash, that's why we got, and then we are substituting. This time we can substitute because there are no zeros in the denominator. Okay, ma?
Okay, sir.
Okay, so now we are given this function. This function, what exactly do we do? Because the denominator is clearly 0, 0 into cos x. Okay, and the numerator is a power 0 minus 1, that is 1 minus 1, 0 by 0. Agreed?
Yes, sir.
One option is you differentiate numerator and denominator and then you write f dash by z dash and try again substituting 0. Okay? Okay.
Okay, sir.
That is one option. Okay, but in some cases, what will happen is if you differentiate these kind of things, no, you will again get some products, and some products, whatever. Some of them will be 0 and then again you will get a 0 in the denominator. Okay, rather what we are trying to do is we are trying to just manipulate this a bit. Okay, what we are trying to do is a power x minus 1 by x, this we know this limit, right?
Yes, sir.
So that's why what we are doing, there is a x here and there is a sin x here. What we are rather doing is we are dividing and multiplying with sin x. Okay, ma?
Okay, sir.
Then we are combining this part will become 1. Agreed?
Yes, sir. Sorry.
Agreed. So then we are
Yes.
combining this part also will become 1, right? Sin x by x. A power sin x minus 1 by sin x. We are taken this and then this and the cos x will be left. Okay, now we can substitute. Okay, we know this part is 1, this part is 1, and this part is also, sorry, this part is ln a, this part is 1, and this part is 1. Okay, that's how we got this. Understood?
Yes, sir.
Yes, sir.
Okay, so we have used this one, a power x minus 1 by x. This is the standard form. Limit x tends to 0 is ln a. Okay, ma?
Okay, sir.
Okay, cool. So next one, see here, this one we have to find out what exactly is the limit. Okay, so this is, if you observe, this is actually in the format of 1 plus x whole power 1 by x when limit x tends to 0. Agreed? Because
Yes, sir.
this part is 0. Okay, now we want to actually bring this in this format. Okay, how do we do this? How do you do this? This part we are just multiplying and dividing with x squared plus 3x. Okay, let me do this. 1 plus x squared plus 3x is there, right? This part is tending to 0. Agreed, when x tends to 0, right? Now 1 by sin x is there. What we are doing, we'll again multiply with x squared plus 3x by x squared plus 3x. Okay, ma?
Okay, sir.
Okay, now this becomes what? 1 plus x squared plus 3x. Okay, 1 plus some t whole power 1 by t. Okay, this times x squared plus 3x by sin x. Agreed? We can
Yes,
write
right,
it
sir.
like this, no? Agreed, ma? You can write this
Yes,
one
sir.
like this. Agreed?
Yes, sir.
Okay, now this entire part is equal to what? 1 plus x whole power 1 by x. This part is equal to e, right? This part is actually equal to e, no?
Yes, sir.
Right. 1 plus x whole power 1 by x. This is in this format, right? This part is actually equal to e. Now we are replacing this, then this becomes e power x square plus 3x by sine x, right? By sine x. Agreed, ma? Agreed.
Yes, sir.
Okay. Now what we are doing? This will write as x into x plus 3 by sine x. Okay. Now again sine x by x, this becomes 1 and this becomes 3 plus 0, 3. So finally we have got it as e cube. Understood?
Yes, sir.
Are you pretty clear here what we are doing?
Yes, sir.
Okay. Please do this yourself once and convince yourself that this is actually turning out to be e cube or not.
Sure, sir.
Just quickly within a minute, you just finish it off.
Okay, sir.
Sir, can you repeat once again?
This part, just do it yourself once and see that you are getting e cube or not. Okay, ma?
Sir, I'm not getting this question. Can you explain?
Okay. So what we are trying to do this is this part. Okay. We are trying to get this in the format of 1 plus t whole power 1 by t. Okay. X is tending to 0. Obviously, this thing is also tending to 0. Okay, ma?
Okay, sir.
Agreed? Okay. Now what
Yes.
we are trying. Now this one x square plus 3x. This is there, no?
Yes, sir.
Whole power 1 by sin x is there. Okay. So now I want 1 by t. Let's say this is t. Okay. I want some x square plus 3x here. Okay. So for that, what I am doing, I am multiplying like this. I can do this, no?
Yes, sir.
Okay. Now what I am doing, I am just rewriting this. Okay. This part is this. Let's say this part is t. This becomes what? 1 plus t whole power 1 by sin x into
Fine.
t by t. Agreed?
Okay, sir.
Agreed, no?
Yes, sir.
Okay, this I can rewrite it as 1 plus t whole power 1 by t into t by sin x. Agreed?
Oh, yes, sir.
We can write it now? Okay. So now this means this, let's say this is a power m into n. What does that mean? A power m whole power n, right?
Yes, sir.
Okay. This part, okay, so this part, a power m, we call it, we can write it like this, no? 1 plus t whole power 1 by t whole raised to the power of t by sin x, right?
Yes,
Agreed?
sir.
Okay.
Yes, sir.
This part now we are clear. Earlier also we are clear. As long as t is tending to 0, 1 plus t whole power 1 by t, this is equal to e, right? So this has
Yes, sir.
become e power t by sin x, right?
Hmm.
Agreed? Okay.
Agreed, sir.
So what does it mean? E power, what is t? T is our x square plus 3x, right? X square plus 3x by sin x, right? Agreed,
Yes,
ma?
sir.
Which is
Agreed.
nothing but e power x into x plus 3 by sin x, right? Agreed?
Yes, sir.
Now again, see this part, when x, this part, right? When x is tending to 0, x by sin x or sin x by x should tend to 1, right?
Yes, sir.
So this means this actually converts to e power x plus 3, right? This part is anyway 1. Okay. Again, this is all limit extends to 0. That means now we can substitute the x equals to 0 and this becomes e cube. Understood, Mark?
Yes, sir.
Understood. So basically, what we are doing, we are trying to convert this into e power. So e power. We are trying to get this into the format of e power x. Okay. For that, what we are
Okay,
doing,
sir.
there is this because we sensed something 1 plus 0 whole to the power infinity. This kind of 1 power infinity. This kind of form we sensed here, right?
Yes, sir.
Ultimately, this is in that format. No, see, this part is tending to 0 and 1 plus 0 whole power 1 by 0, that is infinity, right? 1 power infinity form we have sensed. Okay. And 1 power infinity form, because we have found, we used our knowledge which we obtained here. 1 plus x whole power 1 by x is actually equal to e, right? So
Yeah.
that's why we converted all this thing to the power to e power something. Okay? E power this thing. Okay, ma?
Yes, sir.
Understood now?
Yes, sir.
Okay, very good. I think if you do some more problems like this, no, you'll get a hold. Okay. Now see, sin x power x. What is this format? This is 0 power 0. Agreed?
Yes,
Agreed,
sir.
sir.
Okay, this is 0 power 0. Now we cannot, this is kind of indeterminate. So this kind of forms, how do we understand? Okay, what we do, we'll assume this equals to sin x power x. Okay, ma?
Okay, sir.
Sin x whole power. This is not x power x, this is this function whole power x. Okay, ma?
So now we take log.
Now we take log, exactly. If you take
So
log, what
log
will
y
happen?
equal to log sin x raised to x.
Log y equals log
Log
sin
sin
x
x
raised
raised
to
to
x,
x.
which is nothing but x sin
X log sin x.
x log sin x. Okay, fantastic.
Yes, sir.
Everything very good. But sin, this is in what
X
format?
in
0 times. Okay, so what is sin x? Ln 0 is tending to what? This is tending to infinity, right? Negative infinity, right?
infinity. Yeah.
Negative infinity. This is in the format of 0 times infinity. Negative or positive doesn't matter. Okay.
Okay, sir.
Okay,
Okay, sir.
so this time what we are doing, we are sending x below. Okay, how we are sending? we'll write it as ln sin x whole by 1
by
by
x.
x. Okay.
1
This
by
is
x. Yeah.
becoming infinity by infinity format. Negative, positive doesn't matter. Okay, ma?
Okay, sir.
Okay. So now because it's in infinity by infinity format, we'll differentiate numerator and denominator. Okay. Because,
Oh, yeah.
right. So if you
Yes,
differentiate
sir.
ln sin x, what will happen? Tell me.
1 by sin x. 1 by
1 by
sin x.
sin x, and you still have to differentiate sin x,
Into
right?
sin x. Into sin x.
Into
Yeah.
minus cos x. Sorry, into
Yeah.
cos
Okay.
x.
Yes, sir.
Right. Sin x, if you differentiate what, you will get cos x, right?
Cos x. Yeah.
And 1 by x, if you differentiate what, you will get
Log
minus
x.
1 by x square.
Okay, never mind. Minus 1
Agreed?
by x square. Yes, sir.
Yes, sir.
Okay. Minus 1 by x square. I think he has done something wrong. Log sin x, you should get, this should be positive only. Okay. Okay. So
We
log
are
sin x, if
correcting
you differentiate, you will get 1 by sin x, and sin x, if you differentiate, you will get cos x. Okay. There
cos
is no
x.
negative
Cos
now.
x by sin x minus 1 by
Right, right, right. So ultimately, what you are getting?
cos x by sin x.
Cos x by
Sin x
sin x.
by 1 minus 1 by x square.
So that means this x square you can send it here, right?
Okay, yeah. Minus x square cos
Agreed?
x by sin.
Okay.
Yes, sir.
Now this means what? Minus of x times cos x by sin x, right?
Yes, sir.
Okay. Now this we can combine. This part limit is actually equal to 1, and this one is 0 into 1, which is actually equal to 0.
Yeah.
Understood?
Yes, sir.
Okay. Or otherwise, if you want, you can further differentiate also. Okay. Let's say this is again
Okay,
in
sir.
0 by 0 format. Okay. You are not satisfied here. This is in 0 by 0 format now.
Yes, sir.
Agreed. So x square cos x by sin x, or negative x square cos x by sin x, this is still in 0 by 0 format. Now what you'll do? You differentiate this again. What will you get? Minus of x square into minus sin x, right?
Yeah.
Okay.
So,
Plus,
sir,
Sir,
why
won't it be
aren't
2x
we
minus
2x,
1?
sir? Why won't it be 2x
no,
into
no, why are
minus
we
sin?
doing? Because this is still in 0 by 0 format, right?
Okay.
This is still in what is, as long as it is in 0 by 0 format, we can continue doing, no?
Sir, but won't the x square also differentiate though
That
to
is, let
2x?
it be. We are differentiating, no?
Okay,
Understood?
Okay,
sir.
sir. You just use chain rule here.
I'm just using chain rule.
Understood, sir.
This
Understood, sir.
negative sign I'm keeping it outside. First function into differential of second function plus second function into differential of first function, right? U v
Okay,
dash
Okay,
plus
okay.
v
got it.
u dash. Okay, ma?
Product rule. Yes, sir.
Okay,
Product
sir.
rule, right? Differentiate, if you differentiate sin x, you are getting
Cos
cos
x.
x.
Cos x.
Okay. Now the denominator is no longer 0, right? Cos 0 is 1. But numerator is 0 because there is 0 here, 0 here. 0 into something, 0 into something. Okay. Now we are getting 0 by 1, which is equal to 0, right? Now we can
0.
directly
Yeah.
substitute, no? X equals to 0.
Hmm.
So there also you got
Yes.
0. Either you stop here and call and use sin x by x and call it 1, and this one as 0, or you go one step ahead and still reach here. Understood?
Okay, sir.
Ultimately, what is the limit? The limit of sin x power x is actually
Will
equal
be
to
1. 1.
0, 0.
Oh, never mind.
You got 0, no?
Yes, sir.
Okay. Okay, good. Next one. See this? X minus mod x by x when x not equals to 0 and when x equals to this is this. Okay, ma? Okay. We have to find out what exactly is whether the limit holds or not. Okay?
Okay, sir.
Sir, it doesn't hold.
It doesn't hold. But why it doesn't hold?
Sir, because left hand limit isn't equal to right hand
Right
limit.
hand limit.
Right, right. Left hand limit, how do you evaluate? When you put x as, let's say, negative 0.01. Okay? then that is different. When you put as positive point 1, it is different. Okay, ma?
Okay, sir.
Agreed. Okay, okay. So try to calculate. Tell me what is the right hand limit of this.
So it's 0.
Right hand limit is 0. Why?
0.
0 by x, so it's 0.
0 by x. Right hand limit is 0. Oh, what is the left hand limit?
So it's 2.
2. 2.
It's 2.
Right?
Very good.
X
Very good.
plus x by x.
Okay, okay. Now tell me about this. This one. Sin x by x, the step function.
So it's 0 and 1, I guess.
Oh, okay, okay. So earlier we discussed sin x by x. Okay. So one thing that you have to remember is sin x is always less than x. That you remember that, no?
Yes, sir.
Okay. So the graph of sin x will go like this, and the x it will go like this. Okay, leave it. Uh, this is the line y equals to x. While we discussed, right? This y equals to x is a tangent to the graph y equals to tan x as well as sin x. Agreed?
Yes, sir. Agreed.
Agree, ma? So tan x will always go above this y equals to x, and sin x will always go below this y equals to x. Okay, ma?
Okay, sir.
While x tends to 0, when x tends to 0, sin x and tan x, they will come closer. Okay, I'll show you the. Do you remember the. Right, right, right. Do you remember this graph? Sin x by x graph, right?
Yes, sir.
Okay, in this graph, what is happening? When x is coming close to 0, sin x by x is actually getting close to 1. Okay, ma? There's a hole,
Hmm.
obviously. At 0, there will be a hole, right? But the limit is actually equals to 1. Agree?
Yes, sir.
Agreed, sir.
Agreed, no? So what does that mean? At any point which is slightly towards the right side, this value is lesser than 1, no? It is trying to reach 1. This value is less than 1, right?
Yes, sir.
Okay, what does that mean? The step of this value will actually become 0, right?
Yes, sir.
Agreed? The step of this value will actually will become 0, right?
Yes, sir.
Yes, sir.
Agreed. So this is one way of looking at this. The another way of looking at this, y equals to x. What is the slope of the line? Y equal to x. The slope of this line is 1, right? Agreement?
Agreed.
Okay, y equals to sin x. What is the slope of what is the slope of this one? The slope of this one is cos x, right? Y dash is cos x, no?
Hmm.
Okay. So what essentially we are saying is sin x and x both are zeros at 0, right? And y equal to x is actually going at this line, this direction with a slope 1, right? And
Yes, sir.
why this sin x, this graph is actually going at a slope which is cos x, and this slope is always less than or equal to 1. It is 1 only when it is 0. Otherwise, the slope is lesser, right? Agreed?
Yes, sir.
Okay, what does that mean? This graph will actually, both are starting at the same point. One is going at a slope 1, another is going at a slope lesser than 1. Obviously, this one will be lower than that graph. Agreed?
Agreed, sir.
Agreed, no? You are very clear now here?
Yes,
Okay,
sir.
so that means sin x graph will always lie below this line y equals to x. Okay, what does that mean? The value of sin x is always lesser than x, right? So that's why this ratio when x tends to 0, this because this number is less than 1 and greater than 0, this one will become actually 0. Okay, ma?
Okay, sir.
Agreed. And similarly, if you do the other one, right? So for example, tan x. What is if y equals to tan x? What is y dash? Secant square x, right?
Yeah, sir.
And secant square x is always greater than or equal to 1. It is 1 at x equals to 0, right? Right. What does
Yes,
that
sir.
mean? Tan x, the slope is always greater than 1. So x, sin x, tan x, all three are starting at 0. But because tan x slope is greater than 1, it goes above this line y equals to x. Okay, ma? Okay. So similarly, if you are asked this one, tan x by x, What is this value now? Tell me. As x tends to 0 plus, because tan x is greater than 1, this one will become 1. Agree?
Yes, sir.
Do you understand this? Is it very clear here, Amma?
Yes, sir.
Sin x is slightly lesser than x, tan x is slightly greater than x. Okay? That's why when you say tan x by x, this number we are talking about some number like 1.01, 1.1, whatever. Okay? As x increases, tan x will become much bigger than x. Okay? And as x increases, sin x will become much lesser than x. Okay, ma?
Okay, sir.
Okay, that's why tan x by x immediately right after 0, it is slightly greater than 1, and that's why the step function is 1, whereas for sin x the step function is 0. Okay?
Okay, sir.
Okay, very good. Now, see this one. Here we have to calculate this limit. Okay? X plus 1 whole
Okay, sir.
power 10, x plus 2 whole power 10, whatever, whatever. Okay. Now, can we rewrite this like this? What we are doing? We are taking x power 10 common. Basically, we are dividing with x power 10 both numerator and denominator. Right?
Okay, sir.
Okay. Now, what is happening? When x tends to infinity, these all terms will become 0. Right? So, what will be left? You
Yes,
will be
sir.
left with 100 ones in the numerator. And you will be left with only 1 in the denominator. Agreed?
Yes, sir.
Agreed. So, that's why you are getting 100. Okay, ma?
Okay, sir.
Okay. So, okay. Now, this one. And will you give it right here?
Yes, sir.
Uh, just try this. Try to find this limit.
Sir, we have to try with the one with the arrow you marked, right?
This one. This one. This one is anyway done, no? This one you try. The right side one.
Oh, yeah, yeah. Sir, is the answer 1?
Answer is -1. Just check.
Minus 1.
You would have missed this minus somewhere.
Oh, yes, sir. I made a mistake. I got it. I got it.
Got it, no?
Yes, sir.
Both of you got it, no?
Yes,
Sir,
sir.
once again, sir.
Sir, it'll be
The
minus 3
last
by
shift.
3. So it'll be
What, ma?
minus 1.
-1,
It'll be
no?
Yeah,
minus,
but
yeah, minus 3 by 3, so minus 1.
Okay, okay. Very good.
yes, sir. It's -3 by 3.
Okay, very good. This one, where is this one? Okay, this one you are clear, no? The sin x power x. This thing is very very important. Okay, tell me one thing. Here we are. Do you understand this one?
Sir, which one?
This one, sin x power x. This thing is actually on PYQ. This is actually very very important. Sin x power x when limit x tends to 0 plus. We have discussed this earlier. Logarithm differentiation we have done.
Yes, sir.
Okay, so what we have got? We have got x square cos x, I think by sin x, right? Here, I think we have got minus x square cos x. I think there is a printing mistake here. Minus x square cos x by sin x, and then we differentiated this once again. You remember, no? F dash by g dash, right? And you have got this 0. But what is this? Ln y equals to 0. It is not the function is not equal to 0. The logarithm of the function is actually equal to 0, right? No?
Yes, sir.
So what does that mean? The function should actually be equal to e power 0, which is equal to 1. So the limit of this function is actually equal to 1. Okay, ma?
Okay, sir.
Okay, limit of this function is actually equal to 1. Please do it once for yourself to see that the limit of the function is actually equal to 1 or not.
Sir, which one?
This one, sin x power x.
Okay, sir.
Sin x power x, what you have to do? You assume y equals to sin x power x, okay?
Yes,
And
sir.
take logarithms on both sides and keep differentiating
Sure, sir.
until you are not getting 0 by 0 format, okay?
Yes, sir. Sir,
Yes, ma'am.
sir, I'm getting sin x raised to x into sin x plus x cos x after differentiating that.
Okay, okay, no, what you did? You've taken this
Sir,
function as y, right? You've taken
yes, sir.
logarithm on both sides, right?
Yes, sir, I did
Yes,
that.
sir.
X sin x, right? X log
Yes,
sin x. X ln sin x, right?
yes, sir.
Okay, now what does it mean? This one, so to apply LH rule, you have to
Oh,
give
sir, one
this
second.
in 0 by 0 or infinity by infinity format, right? So
Yes,
Sir,
sir.
are
this,
you screen sharing the question now?
oh, is it not? Can't you see?
Sir, it's in the other two questions itself.
Oh, I don't know what is happening. It is not changing, no?
No, sir, it's in the other two
Wait,
questions you told us to do before.
yes, let me reshare this once again. I don't know why it is not showing the screen.
Yes, sir, now it's there.
Is it better? Can you see?
Yes, sir, now I can. Now it's.
It's scrolling, no? Okay, okay.
Yes.
See here, y equal to sin x power x. Okay, ma? What does log y means? Ln y means x ln sin x. Okay, ma?
Okay, sir.
Okay.
Okay, but what we want to find what is y when x tends to 0, not ln y. Our goal is to find what is y. Okay, when x tends to 0. Our goal is to find what is this when x tends to 0. Okay. Now,
Yes, sir.
because we cannot do anything, our LH rule is applied for function by function, 0 by 0, or infinity by infinity. We cannot directly use LH rule for 1 power infinity or 0 power 0 kind of thing. So that's why what we are trying to convert this into some 0 by 0 or infinity by infinity format. That is our first goal. Okay.
Okay,
When
sir.
we take logarithm, what we have got? We have got this one 0 into ln 0. Ln 0 is minus infinity, right?
Yes, sir.
0 into negative infinity. We got this in this format, right? But this is also not sufficient. We want 0 by 0 or infinity by infinity format. So this time what we are doing, x ln sin x, we'll rewrite this as ln sin x by 1 by x. Now this is in infinity by infinity format. Agreed?
Yes, sir.
Negative infinity by whatever, positive infinity, negative infinity, doesn't matter. But still infinity by infinity format. Okay, ma? So ideally what we have done, 0 power 0, we converted this to infinity by infinity. Okay. Okay, but this is still ln y. Agreed?
Agreed, sir.
Ln y, we converted this to infinity by infinity format. Now what does this mean? Now because we have reached this format, we can differentiate numerator and denominator, right?
Yes, sir.
Okay, now if we differentiate numerator, what will happen? 1 by sin x into d by dx of sin x, which is cos x, right? Whole by, what is the
1
derivative
by.
of 1 by x? Minus 1 by x square. Okay, ma?
Okay, sir.
Okay, this becomes what? Minus x square cos x by sin x. Okay, agreed? This is still
Agreed, sir.
ln y. Okay, this is still ln y. Okay, now we are still
Okay, sir.
limit x tends to 0. Ln y is this thing, limit x tends to 0 minus x square cos x by sin x. This is again in 0 by 0 format. Agree?
Yes, sir.
So again we cannot substitute directly 0. What we will do then, we will differentiate this again once again. If we differentiate this one, what will happen? Minus of x square into minus sin x, right? Plus
Yes, sir.
cos x into 2x, right? Whole by cos x, right?
Yes, sir.
Okay, this is limit x tends to 0, right? What is this? Limit x tends to 0, ln y equals limit x tends to 0, this entire thing. What is this entire thing? Now we can substitute x equals to 0 in this, right? Because denominator is no longer 0. That's why you can substitute. If you substitute, what will happen? Minus of 0 plus 0 by 1, right? Which is nothing but 0. Agreed? Agreed, Amma? Are you clear here?
Yes, sir.
Okay. So what does that mean? When limit x tends to 0, ln y is actually equal to 0. Okay. Limit x tends to 0, ln y equals to 0. What does that mean? That means y equals e power 0. Agreed? When limit x tends to 0,
Okay.
what is y? Y is actually e power 0, no? Agree? ln y is 0. When
Yes,
x
sir.
is
Yes, sir.
turning to 0, ln y is 0. What does that mean? Y equals e power 0. Y should be
Y
1, no?
equal to e raised to 0.
Y should be 1, no?
Yeah, sir.
ln y is 0. That just means y should be 1, right? But what is our
Yeah,
y?
sir.
Y is our original sin x power x, right?
Hmm.
So that's why sin x power x is actually equal to 1, okay? When x tends to
Okay,
0
sir.
plus, okay? I'll show it in the graph also. Please remember this. This is actually very, very important. Okay. Can you see my screen? Sin x power x. See the graph when x is actually tending to 0, sin x by x actually is actually moving towards 1. Okay, ma?
Okay,
Okay,
sir.
sir.
Forget about when x tends from left, because when power minus 1 and sine of minus x, that is actually difficult. So that's why the question is only from when x tends to 0 from the right hand side. Okay. Similarly, x power x also. Please remember, this is also very important. X power x, same logic, we can show that when x is tending to 0, from the right hand side, x power x is actually tending to 1. Okay?
Okay, sir.
Okay? So, for example, you can take a calculator and say 0.5 power 0.5 or 0.3 power 0.3, 0.2 power 0.2. This will all get close to 1. Okay, ma?
Okay, sir.
You can take a calculator and see. Understood, no? So, this is actually very important. That's why I wanted you to take this special attention. Okay, cool. This part is done, no? Okay. This kind of thing you can do, no? What he's saying this limit exists. What does that mean? When x equals to 0, this value equals this value. Okay, ma? And when x
Okay, sir.
equals to 1, this value equals to this value. You have done these kind of things. You can easily compare and solve, right?
Yes, sir.
Similarly here, when x equals to pi by minus pi by 2, this is equal to this. And x equals to pi by 2, this equals to this. You can compare these two equations. Two equations A and B will get. And you can solve both. Right? Here two equations are made and you will solve both. Okay, ma? You do it
Okay.
afterwards. I'll send the file anyway. You do it afterwards. Okay. Now see here, what is saying? X square minus 1 by x cube minus 1. Okay. There is a hole at x equals to 1. This is obviously not defined. So what is that hole here? He is saying. Now what you will do, there is a common factor that is x minus 1 in both numerator and denominator. Right, Nama? You will just
Yes, sir.
remove that common factor. Okay. This you will write as x minus 1 into x plus 1. This is a cube minus b cube, a minus b into a square plus ab plus b square. You will just cancel x minus 1 and substitute. You will be able to do this, no?
Yeah, this is easy.
This is easy. Please finish this. Okay. Now see,
Yes.
this is interesting. X power 6 by 6 power x. Okay. Now see, this is interesting. X power 6, this is in which format? X power 6 is in infinity power 6. This is in infinity. 6 power infinity, that is also infinity. Agree, ma?
Yes, sir.
Agreed. This is in infinity by infinity format. So what we can do? We want to calculate the limit. We can use LH rule, right? Differentiate numerator and denominator. Okay. If we differentiate numerator, what you will get? 6x power 5, right?
Yes, sir.
If you
Yes, sir.
differentiate denominator, what you will get? A power x. This is a power x ln a, right?
Yes, sir.
Agreed. So keep it like this. Now what we have got? 6 by log 6. Again x power 5 by 6 power x. This is again infinity by infinity. Agreed. X power 5, infinity power 5, 6 power infinity, right? Okay.
Yes, sir.
Yes, sir.
So this time what you will do? We will differentiate this once more. Keep this aside. Then what we will get? 5x power 4 by 6 power x ln 6. Okay.
Okay,
Okay,
sir.
sir.
Agreed. Then what I will get? This one and this one if you combine, then 6 into 5 by ln 6 square, right? Agreed?
No,
By
yes, sir.
into x power 4 by 6 power x.
6
Okay?
power x.
This is
Yeah.
still infinity by infinity. Okay? Then
Okay,
what
sir.
does that mean? You can still differentiate. If you differentiate
Sir,
once
how
more,
did
what?
ln6 square?
ln 6 square, no? Here you got one more ln 6. Earlier one more ln 6 is there.
Oh, okay. Yeah.
Understood? If you differentiate 6 power x, what you are getting? 6 power x ln 6, no?
Yes,
Yes,
sir.
sir.
And then you're multiplying that by
Okay, so earlier we got ln6. So this is still in infinity by infinity format. So what you have to do? You have to differentiate this, right? 6x power 5 by 6 power x ln6. If you differentiate, what you will get? Tell me. Numerator is 6 into 5 into x power 4. Okay?
Okay, sir.
Okay, this denominator ln6 into, again, the differential of this. That is 6 power x ln6, right?
Yeah.
Okay, so what does it mean? ln6 whole square, right?
Yes, sir.
This I am erasing. Okay, 6 into 5 into x power 4 by ln6 whole square into 6 power x. Now this is again infinity by infinity. If you do once more differentiation, what you will get? 6 into 5 into, again, 4x cube, right?
Yeah.
By, again, 6 power x will be one more ln6, right? So this becomes
Yes, sir.
ln6 whole cube 6 power x, right?
Yes, sir.
Right. So if you do this differentiation three more times, x cube will become x square, then x square will become x, then x will become 1, right? So if you
Yes, sir.
continue like this, what you will get? Three more times if you differentiate. 6, 5, 4, 3, 2, 1. And x will vanish finally. Okay? By what
Okay,
you
sir.
will get? ln 6 whole power 6 and again 6 power x will be left. Okay?
Okay, sir.
Now this is not in 0 by 0 format, right?
No, sir.
This is no longer in 0 by 0 format. Okay? This is actually what this is something by this is some number. Some number by infinity format, right? Because 6
Yeah.
power infinity is still infinity, right? So that's why this will become 0. Understood?
Okay. Yeah, sir.
Okay, so this is by using LH rule we have defined. Or otherwise also what we are trying to say is this is a polynomial. Okay, this is an exponential function. Okay, understood.
Yes,
This is a
sir.
polynomial, right? X
Understood.
Yes,
power
yes.
6 is a polynomial. This is what? This is an exponential function. No matter what, however big the power of the polynomial, it cannot beat an exponential function. Okay, let's say even if we put
Okay,
x
sir.
power 2000, okay, versus 2 power x. 2 power x will eventually cross x power 2000. Okay, that's what we are trying to say. Understood? Exponential functions are much faster than polynomial functions. They will take some time, but eventually they will cross. Okay, so for example, uh, a straight line like this and a parabola. Parabola will eventually cross the straight line, no? Whatever is the slope of
Yeah.
straight line. Okay, generally, right? Or x cube will eventually cross x square, right? There's
Yes, sir.
at some point it will cross. Similarly, exponential function 2 power x or 3 power x that will eventually cross any x square, any x cube, whatever. Okay, ma? That's what
Okay,
we are
sir.
trying to say here. So now we understood this limit. Now how did we arrive at this limit is actually equal to 0? We applied this LH rule 6 times. Okay, ma?
Okay, sir.
Okay, sir.
Okay. See here. This is one more interesting thing. Okay. Now this is in what format? Okay. So this one x plus 1 by x plus 2. We can write it like this. Agreed? Just this part x plus 1 by x plus 2. Can we write it like this? See, this is in some format. We don't know how to calculate limit, right? We want to get into some
Yes, sir.
format which we are convenient. Okay. Either 0 by 0 or 1 plus x whole power 1 by x, some kind of this format, right? These are the formats we are convenient. Okay, what we are doing, this we can manipulate it like this. Agree?
Sir, can you explain how?
This one, x plus 1 by x plus 2. If you just divide x plus 1 by x plus 2, what you will get? 1 minus 1 by x plus 2. Agree? You know the
Yes, sir.
basic division, no? X plus 1, if you divide by x plus 2, what you will get? X plus 2, you'll get minus 1, right? What does that mean?
Yes.
X plus 1 equals 1 into x plus 2 minus 1. Which is not, what we are basically saying is x plus 1 we are writing as x plus 2 minus 1. You can write it like this, no?
Yes, sir.
By x plus 2, which is nothing but 1 minus 1 by x plus 2, right? Which is this.
Yes, sir.
This entire part, we can write it like this, no?
Yes, sir.
Okay. So now what we are trying to do is, earlier we have done, no? 1 plus t whole power 1 by t. We have done this kind of format, right? This time we are trying to do the same thing. When x tends to infinity, 1 by x plus 2, it will tend to 0, right?
Yes, sir.
Mm.
Right. So what we are trying to do is this we are trying to get into the format of 1 plus 0 whole power 1 by 0 or 1 plus 1 by infinity whole power 0. Okay? Whole power infinity. Okay, which is nothing but
Mm.
1 plus 0 whole power infinity. Right now?
Yes, sir.
Okay, so what we are doing, there is some x plus 2 here. What we have done, there is a 2x plus 1. We have divided both numerator and denominator with minus of x plus 2. Okay, basically this means 1 plus minus of 1 by x plus 2, right?
Yes, sir.
We are actually dividing this one. We are taking this 2x plus 1 and then we are multiplying with again minus of x plus 2 by minus of x plus 2. Okay, ma? Like last time we have done. Agreed? We are
Agreed, sir.
taking this minus of x plus 2 and multiplying and dividing here. Okay. So why we are doing
Okay.
this? Because we want to remove this part as e. Right. We can remove this. No, this is actually e. Agreed. This is in the format of 1 plus 0 whole power 1 by 0, no?
Yeah.
Agreed. This part is actually E. Agreed?
Yes, sir.
This part is E. Do you agree with this, no? This one we have converted this to 1 plus 0 whole power 1 by 0 format. Okay? When this is E, what we have got? We have got E power minus 2x plus 1 by x plus 2. Right?
Yeah.
Now, what we are doing? We are dividing both numerator and denominator with x. So, E power minus 2 plus 1 by x by 1 plus 2 by x. Right? So, when x is tending to infinity, this part will become 0, this part will become 0. So, we'll be left with E power minus 2. Understood?
Yes, sir.
Okay, so don't worry if you are finding this little tricky because this is the first time, no?
Yes, sir.
Okay, so don't worry. These are if you are finding little tricky because these are limits and you are doing it for the first time. For everyone, in the beginning they will be little tricky. Okay, but once you
Okay,
do
sir.
some problems, no. Now, what I suggest you is you whatever that problems what we have done, no, you feel like you have understood. Right. But still, what I suggest you is once after the class, whenever you have time, no, please repeat all these problems once. Okay. These are basic algebraic manipulations only. So you are understanding the thing, no? The what we are trying to do is there is a limit, but we don't know what is that limit. Okay. There is a limit, obviously. When you plot the graph of this, no, you will get this number. Okay. I'll try to show you that one also. Okay, so for example, what is this function? This function is x plus 1 by x plus 2 whole power 2x plus 1, right?
Hmm.
X plus 1, x plus 1 by x plus 2, right? Okay,
Yes, sir.
whole power 2x plus 1, right? Whole power 2x plus 1.
Okay.
Now, if you see, this one is actually approaching this number. Okay, it's not approaching 0. It stopped it's at some point. Okay, it stopped at some point. What is that point? This point is actually this is stopping at this point. No? This is nothing but e power minus 2. Understood? This is not approaching 0. See, right, this is not approaching 0. Agreed? It is not going down. It is lying flat. Okay, ma? Okay, understood.
Okay, sir.
So e power, let's say I write it as e power minus 2. Okay, let's say y equals e power minus 2. There is this line, right? Okay, can you see this graph is not going below that line. This line
Agreed,
is
sir.
that this graph is actually not going below the line, right? Agreed. Agree, Amma? This,
Agreed, sir.
this red graph, it started above the line, and it is this black line is actually becoming a tangent to this red graph. Okay, what does this mean? This graph is approaching this value, but it is never crossing this value. Okay, Amma? Okay.
Okay, sir.
So find out this value. So we know that this is approaching some value. What exactly is the value? To find out what is that value, we are using these different ways. Okay. This is one way. Later, you can actually use 1 power infinity. You can take logarithm of this. Okay. So you can actually you assume this as this thing. Now you take ln y. What will this become? 2x plus 1 into ln x plus 1 minus ln x plus 2. Agree? You can do this also, by the way. Do you agree with this statement?
Yes, sir.
Ln y. Now ln x plus 1 and x, this part will actually become 0, right? Ln x, when x is infinity,
Yes, sir.
ln x plus 1 and ln x plus 2, they hardly matter, right? Now, but 2x plus 1, this is infinity. What you do, you send this 2x plus here, 1 by 2x plus 1. Now this becomes 0 by 0 format, right? Agree? This is 0 by 0 format, right? 1 by infinity, that is 0, and infinity minus infinity, I mean, this is also 0. Agreed, Amma?
Agreed, sir.
Okay. Now you can differentiate. You can differentiate. You can follow this way or this way. If you differentiate, what you will get? 1 by x plus 1 minus 1 by x plus 2, right? But if you differentiate 1 by 2x plus 1, what you will get? Tell me. Minus of 1 by 2x plus 1 whole square into 2. Agreed?
Agreed, sir.
Agreed, Amma? Okay. So now this becomes
Yes,
what?
sir.
X plus 2 minus x plus 1 by x plus 1 into x plus 2, right? Whole of this, or you can send this one to the top. This becomes 2x plus 1 whole square. What is that? 4x square plus 4x plus 1, right? By minus 2. Agreed?
Yes, sir.
Agreed, ma? So here what will get? X plus 2 minus x plus 1. This becomes 1, right? 2 minus 1 is actually 1. So essentially what we are getting? 4x square plus 4x plus 1 by negative 2 into x square plus 1x 2x plus 3x plus 2. Right now? Agreed?
Agreed, sir.
Okay, so
Agreed, sir.
essentially what we are getting 4x square plus 4x plus 1 by minus 2x square minus 6x minus 4. Okay, what is this limit? Ln y. Okay, ln y equals to limit x tends to infinity, right? This one, right? Now you divide both numerator and denominator with x square. This limit you know how to evaluate, no? If divide both numerator and denominator, what you are getting? 4 plus 4 by x plus 1 by x square. Agreed, ma? By minus 2 minus 6 by x minus 4 by x square. Agree?
Yes, sir.
But next tends to infinity. This is 0, this is 0, this is 0, this is 0. So we'll be left with 4 by minus 2, which
So
is
it's
equal to
minus
minus
2.
2. That's it. So ln y equals to minus 2. So y equals e power minus 2. This is what we have got here. Okay? Understood? This
Okay,
time what we have done? We have taken the logarithmic route. Okay, logarithmic differentiation LH rule that we have used. But you should know both methods. You understood? Here we have slightly modified. Here what we have used 1 plus x whole power 1 by x format we have used. Here what we have used, here we have taken directly logarithms, okay, and we converted into 0 by 0 format and then differentiated both numerator and denominator. That's it. Okay, ma?
okay, sir.
Understood, no? So these limits, what I suggest you is please do this once again. Okay. If you do these things, no, then
Yes,
you
sir.
will get more comfortable. These are very, very important. Okay.
Okay, sir.
Okay. Don't worry if you are
Yes, sir.
if you are finding it little tricky, then also don't worry. Okay. In the initial days, they will
Okay.
feel little tricky. That is fine. And because this is the first time you are getting exposed to this kind of problems, no? Because otherwise, say for example, algebra and all,
Mm.
you have been doing it from right say class 6, class 7, whatever, right? But this
Yes,
calculus you
sir.
are getting exposed for the first time. Okay. So that's why it will be little tricky.
Okay,
Don't
sir.
worry. Keep doing little practice. At least do the same problems that we have done. Okay, ma?
Okay, sir.
Sure,
Okay.
sir.
Okay. So then we'll connect on the next class. Next class is Monday only, right? This time
Monday.
Yes, sir,
Monday
Monday.
evening. Okay.
Thank you, sir. Bye,
Cool
sir.
then.
Have a
Take care.
nice
Bye
day.
bye.
Thank you, sir. Bye, sir.
Bye, ma.